Okay, Assalamualaikum and good day everyone. So today we are going to continue with chapter 5, which is the function and graph. So for this chapter we have 4 subtopics. The first one is about the function itself, and then the composite function, and then inverse function, and the last one is exponential and logarithmic function. So mostly you've learned about composite and inverse in high school in chapter 1 form 4. And then functions, we know already the meaning of function itself from your maths. Oh, I forgot that some of you didn't take maths. Okay, so this function, so for the person that have taken maths in SPM, so there will be an upgrade in types of functions. Okay, for those who didn't take didn't took any maths in SPM, so you will learn a new topics here. So we have to know what are the functions means, and then to know how to find the composite function or find individual function from the composite function. And then the third one is to find the inverse of function, and the last one is exponential and logarithmic functions. This 5.4 is really special. We are going to relate with chapter 2. So, the learning outcome for today's lecture, at the end of the lesson, students should be able to define a function. How to define a function? Identify function from the graph by using vertical line test, VLT. Sketch the graph of a function. So, you know how to sketch the graph. And the last one, to state the domain and range of a function. Okay, so we start with the relation of a function between numbers. Okay, a relation is a relationship between sets of values. In maths, the relation is between x values and y values of ordered pairs. The set of all x values is called domain. The set of y value is called range. So there will be two values. The one we represent it as x, the other one will be y. So the relation is the relationship between these two values lah. So what are these y and x are talking about? What are their relation? Okay, like you and your, let's say let's say your mother and your cousin. So what are the relation between your mother and your cousin? Okay, so your mother, for your mother perspective, your cousin is her niece or nephew, but for your cousin, your mother is her or his aunt. Okay, a relation can be represented by, so the first one, by an arrow diagram. So this is what we learned in high school. So we have a set A, which is the domain, and then set B, which is the codomain, or everything here is a range. Okay, so the name is codomain. Why codomain? Because some of the set B might not have Y. Not have Y. The Y inside the B cannot have X here. Okay. The second one, ordered pair. So another representation is ordered pair. So this is what we use. So we found it in the geometric coordinate in mathematics modern. So this is an X, this is an Y value. And a graph. So for the graph, so what is the X? What is the first value? So we know the first value previously it's 2 and 4. So we represent the dot as x as 2 and y as 4. And the second one is 5 and 10. And then the third one is 7 and 14. Okay? There are 4 types of relation. One-to-one means that everything domain, every values in A will have a partner in B. Okay, only one partner, A to D only. So A relates to D only. One element to one element. One element map to one element. Okay. One to many. So how about one to many? Means that an element in A will have more than one element in B. So one element B, we have mapped to one element. But for this one element A, it mapped to two elements. So it can map to many elements in B. And then the next one, many to one. Means that from set A, they will have multiple of element mapped to the same element in B. Okay, let's say for one element, C is mapped to one element F. But for A and B, there are two elements that map into two same element D in B. And last one is many to many. So it can be many to many also. Okay, for this one, A and B is mapped to D, and also C mapped to D, so many to one. And then B also can map to many element, which is D and F. That's why it's called many to many. Okay, so function. A function is defined as a relation which every element of set A is matched with only one element of set B. Means that it has unique image. So every element, so must every element in A must have a match, but matching with only one element of set B. So what is the relation of this function? So the type of relation of this function, a function is a one-to-one or many-to-one relation. Why? Because we want only one element of set B. For one-to-one, it of course will be 1 and 1. But for many-to-one, it may be more than 2 or 3 elements in A that have the same element in B. But it will still have an unique image. For example, so we have set A and B, and in F, in the set A, we have A, B with mapping to D and E, 1 to 1. But for C, it's not mapped to any element. But for the definition of function, it said that every element in set A. So is this a function? So this is not a function because there is an element that in A that has no image in B. If F is the map if F is that maps element from set A to set B, every element in set A will have element in set B. Doesn't matter is the same element in set B or different one. So for this one, set A is equal to ABC is called the domain of F. Every element in set A is called the domain, and every domain here has their own codomain or their own, sorry, not codomain, their own image. But in set B, we have element of D, E, F. So every element in set B, we call it as codomain. But how about the one that has been mapped from A to B? D and E, we call it as range. So every element in B that has been mapped, has coupled from set A, we call it as range. Codomain is every element in set B, but range is different. Range is the element in set B that has coupled in set A. D is the image of A, E is the image of B and C. Okay, a function f from x to y is onto function if for every y in y, there is an x such that fx is equal to y. That is to say, a function is onto when its range equal to its codomain. Means that every element in set B, if we relate to the previous part, every element in part B have a couple in part A, in set A. Okay, means that its range should equal to its codomain. Yeah, every codomain will be the range. Okay, for example, this one, x and y on the left side, A, B, C all are being mapped, and y also have a couple from the left side. So this is one-to-one function because it's mapped to 1, 1 only, and it's onto because every element in y has been mapped. But for the right side, it's a one-to-one function but not onto. Why? Because there is an element that haven't been mapped with the element in X. How about this one on the left side? So every element on X have element on Y, and element on Y, everything has been mapped. So it's a many-to-one function. Many-to-one function is a function, okay, and it's onto because everything is mapped. But for the right side, it's a many-to-one function, but because we have one entry that haven't been mapped, so it's not an onto. Not onto. It's many-to-one, but not onto. Okay, so what is the use of vertical line test? So to test if a graph displayed is a function, vertical lines are drawn parallel to the y-axis. So the graph is a function of if each vertical line drawn through the main cuts the graph at only one point. This is called vertical line. Okay, so let's see some example. Consider the graph shown below and state whether they represent functions. Okay, so this is a graph. So you don't know what type of graph is this, but to show whether this graph is a function, represent a function or not, what you need to do is to use the vertical line test. So what is vertical line test? Vertical line test, it should be parallel to y-axis. So this is your y-axis. So we draw a line parallel to y-axis, and then what we should do, we have to move from the left to the right or from the right to the left to check whether the vertical line will pass at one point only. One point at the graph only. So here it cuts through only one point. Okay. If we move it to the right side, it also cut at one point. Here also cut at one point. Okay, so it is a function. How about this graph? So this type is actually a surd function. So if we move this line around, it actually will cut through 2 points. Okay, so it is not a function. Okay, this is not a surd function. Surd function should be half of it. So later we will learn about it. Okay, how about number 3? So if we move around the vertical line, or maybe if you draw on your paper, you can test by using your ruler. So move your ruler and check whether it will cut through at 1 point or will cut through at 2 points or more than 1 point. So for this number 3, the line x equal to 1 cuts the graph at only 1 point. So it is a function. It may be x not x equal to 1, so it can be anywhere. So please check. move around the ruler. And then for number 4, so this line cut through at 2 points. So if we put the line here, it will cut through at 1 point only. But if we move around, it will cut through at 2 points. Okay, so this is not a function. So the graph of a function. The most common method of representing function is by means of a graph. Each graph is drawn with the coordinate axis. So we have the x and y axis. Graph. For your syllabus, we will have these 7 type of graph. Okay, the first one is linear. It's actually we have the constant graph. Okay, for constant graph, I will explain later lah. Constant graph is really simple. So for every value of x, y will equal to a constant. So your graph, it will be the same value k. So that's why we have a constant graph, which is the horizontal line. So this is your fx. This is a constant graph. So it's really simple for constant graph. That's why we didn't put it in the list. So the first one will be the linear. You've learned in high school, and then quadratic also, you know how to draw a quadratic graph. And then the new one is the cubic function. And then we have square root function or set function and absolute values. So absolute values, so absolute function, and then reciprocal function, and the last one is piecewise function. So this piecewise is really special. Okay, the next one you have to know what is the domain and range. So the domain of the function is set of all first component of the ordered pair of the function. Means that the x lah. The range of a function is set of all second components of the ordered pair of the function. So method to determine domain and range of a function, we can use algebraic approach or graphical approach. So for algebraic approach, by using algebraic approach, the domain of the function are the value of x where y is defined, whereas the range of a function are the values of y where x is defined. So for graphical approach, the domain and the range of a function can be determined by means of a graph. The horizontal axis x represent the domain and the vertical axis y represent the range. So we have to look which value of x and y that has been mapped in the graph. Okay. For example, so this is our graph. From the graph, the domain and range of this function. So if we want to use the graphical method, because they give you graph, so we look at the value of x. So the value of x, the map has been mapped from where to where. So it should be from the left side of x-axis to the right side of x-axis. For this one, the domain is from -3 to 3 inclusively. So we can write down in interval form or set. Okay, so this is interval form or set. So solution set, we learn it in chapter 1, how to write down in solution set and interval form. And how about the range? So we look at the range, the value of y from the bottom up to the infinity up there. So we can see that the range is actually starting from 0 up to 9 only, inclusively. So you can give in the form of interval form or solution set. So let's move on to the type of function in our syllabus. So we have to know the basic shape of a function, all the 7 different functions. Okay, first one is the linear function. So let's say this is the general form of our linear function, fx equal to ax plus b. So the domain for this type of function, fx is defined for all value of x. So our domain is a real number. It starts from -infinity up to infinity, unless it given in the question the domain is a certain interval only. If not, then directly it will be the real number. How about the range? Now we want to find the value of y so that x is defined. Therefore, we rewrite equation with x in terms of y. So we rearrange the x in terms of y. So fx is our y lah. So let x as the subject. So we have ax equal to y minus b. So x is equal to y minus b over a. So it is clear that x is defined for all value of y. Why? Because if we put any value y in here, we will get a value of x. It will have a value of x. It doesn't matter because a is a constant, b is a constant, so there will be a value for x. So means that the range for what? For this function is equal to real number also. It will define all value of y. Okay, let's do example. Sketch the graph of fx 2x plus 3 and find domain and range. So how to sketch a linear graph? So usually at school, what you do is just choose one or two value of x. We choose two values of x and then find the value of y and plot it and connect the 2 points and find the straight line of the linear graph. Okay, so let's say we take when x equal to 0. So what is the y? So we substitute x equal to 0. We have 2 multiplied by 0 plus 3 equal to 3. And then the second value if y equal to 0 and x we get negative 3 over 2. Okay, for this one, they take the y-intercept and x-intercept. It doesn't matter. So you also can take when x equal to 1. So y equal to 2 multiplied by 1 is 2. So it will be 5. So we have 2.03 and 1.5. For this example, they use the y-intercept and x-intercept. So here will be negative 3 over 2, 0. So we use these 2 points to plot the graph. So we put the 2 points and then we connect the 2 points and we get the straight line. Make sure you graph the point, sketch the graph more than the plotted point only. More than the plotted points, not only from the plotted points. Okay, so this is our linear graph. How about the domain and range? So we directly know the domain and range for a linear will be, yes, a real number from negative infinity to infinity, and the range also from negative infinity to infinity. Okay, so let's do some example on sketching the linear graph. So sketch the graph of the following function and determine its domain and range. So first fx equal to x plus 5. So the 2 points we have when x equal to 0, y equal to 5, when y equal to 0, x equal to negative 5. So plot the 2 points on the graph. So we have 5 and negative 5. And then connect the 2 points to find the straight line. So it will be this graph fx equal to x plus 5 lah. So from the graph you can see that the domain and the range is from negative infinity up to infinity. Okay, so for graph B, fx equal to negative x plus 2. The same thing we do is to find the 2 points. We use the x-intercept and y-intercept easier lah. So when x equal to 0, y equal to 2. When y equal to 0, x equal to 2 also. So what do we have here? We have 2 intersect at x-axis and y-axis. So connect the 2 points. So we have a straight line here. So we can see that the domain and the range is from negative infinity up to infinity. Okay, it's really simple for linear. Okay, the next one is quadratic function. So this is a basic general equation of quadratic function. So for function, we will have f as the subject lah. So fx is equal to ax squared plus bx plus c. So what is the domain? The domain for quadratic function is defined for all value of x. Thus, the domain of function is real number, means that it starts from negative infinity up to infinity. Okay, but for the range, we need to find it by applying the completing the square fx, which is can be written as a factorize out the a of x squared plus b over ax, and then complete the square, everything inside the bracket. So what we have is x plus b over 2a all square minus b over 2a all square. Okay, and then plus c, and then we have the final a multiplied by x plus b over 2 all square minus b squared over 4a plus c. And then after that, after we simplify the constant on the right side, what will we have? This is a constant, right? This is a constant. What we need is to open the bracket. So we have a multiplied by x plus b over 2 all squared only. So by comparing fx equal to a multiplied by x minus h squared plus k, this is what you learned in high school in the form of complete square. What is h? H is the x coordinate of for the minimum or maximum, and then this value k is the y coordinate for minimum or maximum value. So we compare from this general form in a complete square function. So we know that h here is actually negative b over 2a, and then the k is actually 4ac minus b squared over 4a. Or if you know already what is the x coordinate, we can find y by substituting the x into the original function. So we don't have to memorize for the k lah. Just substitute x into the function. For if a is more than 0, fx has a minimum point at hk. Okay, it's a small function, so it will have a minimum point. Okay, but if a is a therefore, so this is our small function. This is the minimum point hk. So how about the range? The range is start from the value of k itself here up to infinity. So the range should start from k up to infinity lah. It's an half open bracket interval. So if a is a less than 0, which is negative, means that fx has a maximum point. So the maximum point is at hk. So the maximum value of y here is k. So our range is start from negative infinity up to k. So it should start from below. It should go from below to above. So the maximum value of y is k. So that's why our range is from negative infinity up to k. So let's do some example. Consider fx is equal to x squared. So how to sketch the graph? So x squared is really the simple function of a quadratic with a constant coefficient of x squared equal to 1, and we don't have any coefficient for the x and a constant. So how to sketch this graph? So basic graph of this, because x squared is a positive coefficient here, so positive of x squared, so it should be a small graph. And then how to find the minimum point? So look at the graph, so it should be x minus 0 square plus 0. So the minimum point should be 0, 0. So this one is our graph with the minimum point at 0. And then based on the graph, we can see that df, the domain, is start from negative infinity to infinity, but the range, it will start from 0 to infinity. Okay, 0 must be included. Okay. So how about another method to solve this graph, to sketch this graph? So you can find the roots of the graph. So to find the root of the graph, what you need to do? Yes, you have to let it as equal to 0. So x squared equal to 0. So x actually equal to 0. Okay, so the roots is at equal to 0, so it will cross at 0 only. That's why we have minimum point and the roots here at 0. Origin. Okay. So let's do question B. Fx is equal to negative x squared plus 2x minus 2. Okay. So we directly know that this quadratic is a set function. So we can do the completing the square to find the maximum point. Okay. So because we have a negative coefficient of x squared, we factorize out the negative first. And then we complete for x squared minus 2x. So what do we have? It will be x minus 1 square minus 1 square. And then open back the bracket. What we have is negative of x minus 1 all square plus 1 minus 2, which is minus 1. And then from here we know that our minimum point or maximum point. Why maximum? Because it's negative sign. So it's a set function. So we have maximum. So we have 1, negative 1 as the maximum. H and K. So the maximum point is equal to 1, negative 1. Okay, so the domain is always negative infinity to infinity. For range, the maximum value of y is equal to negative 1. So it should start from, from negative infinity up to negative 1. How about now, to determine the domain and range using the graphical method means that you have to know how to sketch the graph. So let's say for fx equal to negative x squared plus 2x minus 2 earlier. So to sketch the graph, what do you do? First of all, by the completing the square, we know the maximum point of the graph, the set graph. So we sketch at the negative 1, 1, and then we draw the set graph up to that point. Okay, so it should be the maximum point for that graph. So now, from the graph, we can see that the value of domain is from negative infinity to infinity. But for the range, it's going from negative infinity up to 1, negative 1. It's going from here, from below up to negative 1 only. So this is the maximum point of y. That's why our range is from negative infinity up to negative 1. Don't be confused. Jangan terbalik. Okay. So this is the range. Determine the domain and range of the following function and sketch its graph. So now we want to find the domain and range for this function first. So because it's a functions x squared minus x minus 2, so we can do completing the square, or to find the minimum maximum we can directly use the formula h equal to negative b over 2a. Okay, let's say here domain we know directly is negative infinity to infinity, but for range, let y equal to x squared minus x minus 2. So we complete the square and compare. We get x minus 1 over 2 square minus 9 over 4. So means that the minimum point. Why minimum? Because it's positive x squared, so it should smile. So we have minimum point. So the minimum point will be 1 over 2 negative 9 over 4. Right? So since a more than 0, fx has a minimum point at 1 to negative 9 over 4. So for the domain, we know already. For the range, it will start the minimum point. This 9 over 2, negative 9 over 4 is the minimum. So it will start from negative 9 over 4 up to infinity. Okay. So if you use the formula directly, b equal to, x coordinate or h equal to negative b over 2a. So we have 1 over 2 for x, and then the k, the y coordinate, it should be 1 over 2 square minus 1 over 2 minus 2. So we have 1 over 4 minus 1 over 2 minus 2. So it will be negative 1 over 4 minus 2. So this is negative 8 over 2. So negative 9 over 4. So we get the same value lah. Okay, if you use the formula directly. Now how to sketch the graph y equal to x squared minus x minus 2. Yeah, we know already the minimum point from the completing the square over the formula earlier, and then we know the basic shape of this equal to small function, and to find the x and y intercept when x equal to 0, when y equal to 0. So when y equal to 0, we can factorize out the x squared minus x minus 2. We get x equal to 2 and x equal to negative 1. And then when we have the 2 points lah, 2, 0, negative 1, 0, and 1 x equal to 0, y is equal to negative 2. So we have 3 points here. Okay, so we just have to plot the 3 points and including the minimum point, and then sketch the graph lah. Okay, now we know already the minimum point, the x and y intercept. What you need to do, the next thing is to locate all the points on x and y axis. So it's really helpful if you know the basic shape of the graph, which is it should be a small function. Why? Because the positive x squared. So locate the minimum point, look at the x-intercept, look at the y-intercept. So we have these 4 points, and the basic shape should be small. So we connect all the 4 points. So we have this graph. This is our quadratic graph. Okay, done. For question number B, fx equal to negative 2x squared minus x plus 4. Okay, so this is basically a set graph because we have negative constant in front of the x squared. So what we need to do, the first one, to find the domain and range. So find the domain already from negative infinity up to infinity. How about the range? So the range will be from fx equal to negative 2x squared minus x plus 4. What we need to do is to complete the square. So what we get as the result is that the x-axis, the h is negative 1 over 4. The k is equal to 33 over 8. Since a is less than 0, so it's small, so will be the maximum point. So it will be the maximum value of y will be 33 over 8. So it will be from negative infinity up to 33 over 8. To sketch the graph, so maximum point we know already, negative 1 over 4, 33 over 8. And find all the x and y intercept. So we have y equal to 0. So we have x equal to 1.186 and x equal to negative 1.686. And then when x equal to 0, y equal to 4. So we locate all these 4 points. Okay, so we have all the 4 points. Now we need to locate all the points on x and y axis. So the maximum point, the x-intercept, and the y-intercept, and we know the basic shape is set. So connect all the points on the graph. So we have this set graph for this quadratic. Okay, so this is for quadratic. So please try to do. This is the part 1 of this lecture. We will continue for the second part in this afternoon. So please read the function, tutorial function, and try to do any question they have that you can do lah. Okay? Okay. So continue the second part of this lecture this afternoon or this night, this evening. Thank you.